Hey guys, welcome back to VT GeoChat, the official podcast of the Department of Geosciences at Virginia Tech. I'm your host, Rose McRorty, and I'm joined by PhD candidate Amy Hagen, who is going to be graduating this year. So congratulations, Amy. Today we're going to be talking about her paper, Reconstructing the Redox Environment of the Cambrian Harkless Formation in Nevada, USA, Navigating the Effects of Iron-Rich Clay Minerals on the Iron Speciation Redox Proxy. It's a pretty impressive paper, Amy, but before we get into that, I'm just going to remind all of our followers to please like this video, subscribe to our channel if you've not already, and make sure that you ring that little notification bell because you want to make sure that you never miss one of our episodes. So Amy, go ahead and tell me about your paper.
Sure. So this is work that I started back in, I think, 2019, so it's been a few years. And what I did was I used this paleo proxy. And so if we ever want to know anything about the oceans in the past, we can't, time travel and go measure characteristics of the oceans. So we have to use different elements on the periodic table that correlate with conditions that would have been in the oceans to learn about them. So I used this proxy called iron speciation, and I'm happy to elaborate more about what that is, but it tells you about oxygen levels in the oceans. So I wanted to know about oxygen levels in this specific environment in Nevada, where we had these reefs of early animal reef builders. So the first animals to ever make reefs were living in this environment. And so I just wanted to know, what was the oxygen levels like just prior to these animals building their reefs.
So you're saying Desert Nevada was once an undersea environment?
Yes, very much so. Yeah, it was right on the edge of what would have been the continent back then.
Oh, that's
shallow
cool.
Waters, yeah.
So kind of like modern day Bahamas type environment.
Kind of, yeah, a bit more of like sand and silt coming off of the continent than the Bahamas, but yeah, carbonate limestone rocks like the Bahamas as well.
Oh, that's awesome. Mm-hmm. What a time to be in Nevada.
I know, I want to go snorkeling.
So go on.
So I went to use this iron speciation proxy, so it's a lot of lab chemistry using different chemicals to extract different minerals of iron, and then you compare sort of the ratios of those minerals to tell whether the environment was oxic or anoxic. And while I was doing this, I found that I wasn't really getting the results that I expected. So I did a little investigating, and it turns out that these rocks had a lot of clay minerals that had iron. And so the presence of those was kind of messing up the proxy. So I did a little experimenting and sort of figured out exactly what was happening. So that was another big part of this paper.
Okay, well that's pretty cool. So let's just back up for a minute quickly. So you said that this is telling us about paleo oceans. Mm-hmm. Why do you think that would be important for me? I know why it's important for you, but why would it be important for me or for some of our listeners?
Yeah, so I think understanding the trajectory of the evolution of life is just something that impacts us today, trying to understand why we have the animal groups that we do and why they do the things that they do. So that's sort of one aspect of just understanding evolution and what happened and what conditions animals evolved under. And then there's sort of another importance about future alteration to current conditions and how, the loss of oxygen, say, in the oceans would affect similar animals. Okay. Yeah.
Okay, so you're saying like not only does it tell us where we've been in the tree of life, but it also can maybe tell us where we're going. Yeah. As Earth's oceans change, atmospheres change, as everything about our Earth is, dynamic and always changing, you're saying that this may help us understand how life might adapt to those conditions. Yeah,
exactly.
No, that's pretty cool. That sounds pretty important to me. Yeah. So go ahead, tell me what you did.
So I did some field work. So I went out to Nevada a couple times, and I sampled, hammering off these chunks of rocks.
Beautiful.
Yeah, always a good time.
Classic geologist. Go on.
Yeah, and then I brought them back here, and I crushed them up into powder, and then I did the iron speciation process, which takes like a week to do. Wow. So you're adding like different chemicals, you're letting them sit and dissolve the mineral they're meant to dissolve. Then you can take the liquid and measure how much iron you pulled out of that mineral. And you do that multiple times for different minerals over the course of a week. Okay. So I did that, and then I also did a couple other things just to like double check, because you don't ever just want to do like one thing and then base your whole interpretation off of that. So one thing I did was use X-ray diffraction, which is this technique that shoots X-rays at minerals and sort of analyzes their structure and can tell you what minerals are present. So I learned the I guess 5 or so minerals that are present in these rocks. So I did that for all the samples as well, so I could see what iron minerals I am expecting to see, and if that matches what I extracted using the chemicals.
Oh, that's pretty cool. So did it match?
Kind of. Yeah, the clay minerals were the big difference. There are these minerals, glauconite and camosite, which are green clay minerals that have iron. And they usually form when oxygen is fluctuating in the ocean.
Oh, interesting.
So they're like this marker of unstable oxygen, which is cool. But they did not get extracted by the procedure. But they should be counted because they're containing that iron that is sensitive to oxygen. So that was one of the big findings that we hope will be helpful to other people trying to use this procedure for their rocks.
Okay. So can you tell me more about how that, I guess about your results in general, where do you think this went in terms of what really stood out as saying, okay, this is a good study, this is something we're going to publish, what are the results, what do you think this will contribute to the scientific community?
Yeah, I think the results about the clay minerals will be useful for anyone else that's trying to do iron speciation. Of course, we know that every proxy is never foolproof. There's always caveats to that. So I think identifying that as a potential caveat, so that if other people are trying to do this and their rocks are really green, they might be like, oh, we've got these clays, maybe we should investigate. I also think further work needs to be done. You could make mixtures of these clays and exactly quantify how much is being pulled out. Do some more experimenting to sort of pinpoint how much we're missing when we don't fully extract them. If that makes sense.
Yeah, that does. So do you think that's kind of a logical next step for this kind of study would be, let's move on, let's do maybe more, or maybe we make our own samples and then test how this process works?
I would like to. I think that would be a cool thing to do, get some museum quality pure specimens of camosite and glauconite, and then we could combine them with other minerals that are usually present as well, and then do the extraction series again and see. That way we know exactly how much we should be getting and how much iron would be present if everything were to come out. Whereas these natural samples, we can get a good idea, but we're never 100% sure.
Right, because it's the natural world. And I mean, I know even 2 rocks from the same area can vary in terms of what they're made out of. So.
Yeah, exactly. And these minerals are a spectrum.
Yes.
They can have a lot of iron, they could have a little, and we don't know how much they would have had. Yeah.
So it's kind of a logical next step for this study. I'm curious, so what do you think in particular is really strong about this study? What makes it stand out and say this in particular, this study, as opposed to other papers published on this topic, makes it a really strong study, something that I can, if I were to pick up this paper and say, okay, I'd like to do work along these lines, what would make me say I want to use this paper for a reference in particular?
I think I'm really proud of the experimental design. I haven't seen people have sort of known that clays can be a problem, but I don't think people have tackled it in the same way that I did in this paper, where I, every time I added a new chemical, I told you it takes a week, so I would stop the procedure and I'd go to the X-ray diffractometer and measure the minerals, so I could see after this extraction I got all of the iron oxides, but I missed all of the clays. And so I did that over and over for each extraction. And so I think that really systematically showed that we're truly not getting everything. Whereas if you just compared before and after all the extractions, you might be missing the nuance of what each extraction is getting or not getting. So I was really happy with that, and I think that's a starting point for other people if they wanted to investigate similar minerals or different minerals or make mixtures, like I said. Yeah.
So it's more work putting into it, but you're also getting more out of it is the benefit to that.
Yeah, it was a lot of work.
Yes, it sounds like it.
To stop the extraction, go to the XRD, continue the extraction. Yeah.
Right. That sounds like a lot.
Yeah.
But it sounds like you got good results.
Yeah.
So it's not fun to talk about, but part of science is being transparent about these sorts of things. So what do you think are some of the weaknesses to the study? What could have gone better? Whether it's a lab technique that could be perfected, or maybe you weren't able to include something that you think would have made the study stronger, just anything that you think could have made the study better.
I think one of my goals when I started was to really explain the oxygen conditions for the animal reefs. And I think that's maybe something I didn't quite get to fully do because I got caught up in this proxy development stuff. And also, like, my samples are all shale, but the reef is made out of carbonate, made out of limestone. And so you can't use the same proxy for both carbonate and shale. So I kind of had this gap where I wish I could tell you more about the animal reef and the conditions for that, but I wasn't able to because my proxy doesn't work in limestones. And so that's just something, I don't know if there's much I could have done differently. I guess I could have used a different proxy or tried to sample up as close as I could, but I just wish I could have said more. I mean, I'm happy with the proxy development side of the paper, and I think that'll be useful, but yeah, my conclusions about the reef maybe aren't as exciting as I had hoped.
It's okay. So it sounds like you set out to answer one question or to find out something, and then you ended up along the way developing this technique, and so the paper is really about the technique that you can use to find the answer to your question down the road.
Yeah.
Am I understanding that correctly?
Yeah, that was not necessarily something that I had planned to do, but I'm happy that it worked and allowed me to get a paper.
And sometimes that happens with science. Sometimes point A to B is a little longer and more complicated than we thought, and we end up with point A.1 and A.2 along the way.
Exactly.
So that's pretty good.
Yeah.
So would I be accurate in saying that maybe a logical next step for you would be to, in addition to looking at these different types of clay speciations or proxies, maybe you could also be saying, okay, now let's use this to go back to this big question, which is that you're trying to answer about life development in these reef conditions.
Yeah, I definitely want to explore. I mean, I have like 2 other projects going on that same place just because it's so interesting.
Right.
Yeah, I think, more proxies could be applied to that area, or you could take this information about the iron speciation proxy, and I mean, people use it all the time. It's one of the most used paleo redox proxies that I can think of. So people use it all the time to answer these questions about evolution and extinction.
Right. And so this is just like one last question, because I know you said that you would expand a bit more on the what is the proxy. Can you tell me a little bit, like, is this like a chemical that you're adding to water, or how exactly is this? What is this?
Yeah, so what you do is you take a test tube and you put a little bit of rock powder in, and then the first step is adding sodium acetate.
Okay.
So you make these reagents, you add it in there, you let it sit for, now I can't remember the time, but maybe 2 to 8 hours is like the window that we usually let things sit. And then you can take that liquid and you can go on a spectrophotometer, which is this instrument that measures the intensity of like a color. So we put in this color reagent that makes it turn pink, which is awesome.
Yeah, that sounds pretty.
Yeah, it's really pretty. So however much iron in there is how pink it will turn.
Okay.
So then we can measure it right there, same day, which is pretty cheap and quick, so I like that. And then you would just dump the rest of the liquid out. You still have that powder that you had subjected to the sodium acetate. And then you would add the next reagent, which I think is sodium dithionite. Okay. I might be mixing up the order because it's been a while since I've done this now.
That's okay.
And you just repeat that process 3 times to get out iron oxides, iron in carbonates, and iron in magnetite. Okay. And then you do a different thing to get out iron in sulfides. Okay. So just different iron minerals. You're just trying to measure how much is in each, and then the ratio of all of those versus how much iron is in everything in that rock will tell you how much oxygen there was or wasn't.
Okay. So as I remember from chemistry, iron and oxygen like each other a lot.
Yeah.
So that's why you're using the iron measurements to look at the oxygen levels.
Yeah. So if there was oxygen around, iron oxides would form. Right. Okay. If there's no oxygen around, you would get other things
other types
forming
of
iron sulfides. Okay. like pyrite,
Right.
things like that. So we're just measuring the proportion.
Okay, well that makes a lot of sense.
Yeah.
So that's pretty cool. Is there anything else that you want to add about your paper, or anything else about that in particular?
I don't know. It was really fun. I'm happy with the way it went. I'm excited
Nice.
that it has spurred other projects that I'm working on now.
Yeah.
So one of them, I guess, if you're curious.
Yeah, I'd love to hear it.
Yeah, one of them, while I was studying these rocks, looking at them in thin section, I found tiny cyanobacteria fossils.
Cool.
They're really cute. They're like
and I'm
spiral.
going to pause you right there and just say, when we say thin section, we mean a very tiny, thin little piece of rock that we're looking at under the microscope, and it's really pretty.
Yeah, exactly.
I can geek out all day over thin sections. So go
Yeah.
on. So you found those cyanobacterial fossils.
So yeah, there's like thousands of them.
Oh, that's so cool.
Yeah, they're really densely packed. So I did some examination to figure out what they're made out of now, because obviously they're not still soft organic carbon.
Right.
They're preserved in hard silica.
Right.
So I'm finishing up a paper now to submit soon that talks about, how those guys got in there, how they got preserved, what that means about the environment if these tiny little fossils are getting preserved in silica.
Oh, cool.
So I'm really excited. That was just kind of an accidental finding where I was looking at thin sections from this old paper, and then I found something new. So.
Well, maybe that's a preview for a future podcast episode.
Yeah,
I would love to have
maybe.
you back to talk about that.
Yeah, sure.
I'm pretty interested in that. So
Yeah.
So I guess like my last question for you then that I have is, what do you think the future looks like for this type of research in general? I know that you work with Dr. Ben Gill, and I know he's got a great research grouping program here. How do you think that this particular project how do you think the future looks for this particular project? Do you anticipate a lot more research in the Nevada paleo ocean reef genre, or do you expecting research here in Dr. Gill's lab? Are you expecting research at other places? Maybe that you're personally planning on doing, or maybe just opportunities that you think for other people to come along, especially if any of our viewers are interested in this research and are thinking about graduate school or thinking about where they want to go to college. If you're interested in this, then this could be a really great opportunity for you to go into research-wise. So what do you think about opportunities for the future in this?
Yeah, I know Ben has always done a lot of iron speciation, and he's got it all set up in his lab, and he likes to do it. We definitely do field work in Nevada. I think I've been almost every year since I started geology. It's just a great place to go, especially for first-time field work, because it's pretty accessible. It's just like a couple hours from Vegas.
Right.
It's a nice deserty environment, so I think it's a really accessible place to go for undergrads and grad students, and there's lots of research to be done there. I know Ben likes to use this proxy for other scenarios and settings. I think he's done Devonian, slightly later, or slightly younger rocks as well, and so I think there's plenty to work from this study.
Oh, that's awesome. So it sounds like there are some good opportunities for both you and for future scientists too. So.
Yeah.
I'm always excited when I hear that.
Yeah.
Well, that's all that I have. So unless there's anything else that you want to add, I just want to say thank you so much for being on the show today. I was so great talking to you and hearing about your research. I've known you for a couple of years, but I don't think I've ever sat down and talked about your research like this. So it was really great to do this. And I hope that I can have you back to talk about those fossilized bacteria.
Yeah,
so that'd be really fun. So everyone, thanks so much for watching our show today. If you have any comments, please drop them in the comments below. I love seeing those comments and questions. And so please stay tuned to join us for our next episode next week. And as always, stay lava.